Hello, everybody. Hope you can see my share. Namaskar, first of all. I don't want to be biased for any specific time zone. So Namaskar is far better than good afternoon or good morning because I never know from which time zone people have signed in now. Namaskar, everybody. Myself, Lax, and with me I have Ravi. We are from Intuit. Today's topic is on one of the platform that we built. It's called Modern SaaS Platform. We call it Intuit Modern SaaS Platform. So the talk is going to about that. Before we begin the talk, we would like to understand the participant background. So there will be a poll that will be showing up. If you can just answer the poll, we will get to know the participants' technical domain they are working on and other details. So I'll give 1 minute. So everyone should be seeing the poll. Great. Architect. In fact, just before the talk, I was talking to my wife and then I said, I'm going to talk about modern SaaS. And then she asked me, why are you talking about mother-in-law? Then I said, okay, I cannot talk always nice things. So sometime I have to talk technical also. So today our talk will be mostly on the technical side, how we build the platform and the challenges that we have faced. So depending on the participants' interest, we could focus on one of the area little more than other. All right. I think we have a number. So we have 36% or 43% said others, and we have backend developers 27, kind of mix of audience, DevOps around 7%. Thanks for answering the poll. So we will kind of base our talk based on the audience interest. So the agenda for today is who we are. When I say who we are, it's about Intuit, not myself or Ravi. So it's about Intuit, who we are, and then why we build the platform, which kind of should answer what the modern platform is, and then how we built it and all the challenges that we have encountered while building the platform and while running it. So with that said, who we are, Intuit, the company was founded in 1983, has grown leaps and bounds over the year. And these are the three main product lines that we work on. One is TurboTax, which is for the consumer market. Another one is QuickBooks, which is for small and medium business owners. And then the Mint, which is a personal finance solution. The talk today is the platform on which these products run on. So we are not going to go in details about the products, but the platform on which all the microservices that builds up the platform, builds up this product is running on. So these are some of the recognition Intuit received globally, and these are something at India. So we are #1 company to work for. So of course we are hiring, just let you guys know. We are #1 company to work for, and we are in the top 10 most of the recent years. So these are the places you can reach out us on Facebook, LinkedIn, or Twitter, or all the social media. So with that said, we'll quickly get into the topic, why we started building this platform. So basically it's a platform for the developers, and it's a platform for the developers to run their microservices. So that's the basic thing here. And why we built the platform was, the first thing was we wanted to improve our recoverability from any incident. Incident bound to happen. Whatever is our architecture, the incidents are bound to happen. But it's not about, it's about how fast we can recover from any incident so that we have a minimum or zero customer impact. So that is something we wanted to improve by 10x time. Of course, the XYZ that you see are the actual numbers that we put. Since we are sharing it externally, I cannot share the numbers, the exact numbers, but we had the actual numbers on which we were working on. So we wanted to improve it by 10 times on the recovery part. And then while we recover faster, we also wanted to release the, have a faster release cycle. So the reason we wanted to have a faster release cycle and is for how fast a PR can get deployed into the production system, right? And the reason that we wanted to have that one was faster, because when any developer makes change, or any human being for that matter makes a change, it's very fresh on their memory for a shorter period of time. But as the time passes by, we tend to forget the changes that we made. So if you want to recover anything, it takes little more time. But if we have a PR and then we just deploy it to production, not only we ship the feature to the customer pretty quickly, also if there is an issue, it helps us to recover fast also because the changes made are very fresh in their memory. And of course, as usual, we wanted to have a multiple releases so that we can just ship the feature as and when it is ready. So these were the goals with which we started. And why it was a tough thing for us initially? Because as I said, the company was founded in long back 1983, and many of the product or the application that makes up the product were made as a monolith. So it was a big monolith. The first obvious choice was, of course, break down this monolith into a microservices so that we can do the deployment faster and we can release it faster. Each feature can go on its own. If there is an issue, we can roll back that specific feature and other things, right? So this was great. And then we started telling team that, hey, split your monolith into the microservices and you can deploy into our infrastructure, right? So we had, of course, the in-house data center, which we completely retired a couple of months ago. Then we said, okay, you take AWS and then go to the cloud, and our choice was AWS. You can go and deploy your application there. So all the thing that we wanted developer to do was, okay, I want to develop a service. Then he has to make an entry into the service portal. So that's kind of a catalog we maintain in our org to maintain the details about the service. And then they get a cloud account. In our case, it's AWS, which creates some basic resources. And then they go back and then they create the Git repo because they have to share the code with other developers. And then they create the pipeline to deploy their application or build their application and then deploy it and set up the CD. And if there are an application of specific type, then they'll have to go through the different security review and set up the monitoring and alerting and so many things they have to take care of it, right? So at the end of it, it took a few weeks before he can actually, before the developer can actually set up the service and then run. What we found was there was a steep learning curve involved because every developer had to know about the infrastructure well. Of course, the AWS made the infrastructure much simpler, but it never kind of abstracted from the user. Still, user need to understand what is ingress, what is egress, how do they set up the EC2 instance, or how do they set up the security group to work with the different ingress and other things, right? So still there were a steep learning curve involved. And we ended up having multiple AWS accounts. And this kind of posed the other challenge of how we securely maintain all the accounts so that they are all consistent. If there is some issue find with a specific AMI or a specific image, how do we go and patch all the system at once? So these were the other challenges that it posed. While we try to get our release frequency, we try to get our developer velocity higher, but there are other factors which kind of slowing down our overall progress. So what happened was we kind of ended up with this one. So we split into multiple microservices, and each microservices had different architecture. I mean, everything is right. I mean, for specific microservice, the specific architecture was fine, but we kind of have the architecture being a little bit duplicated or kind of slightly different from each other's. So that way it kind of posed a challenge as when a developer moves from one team to other team, he has to learn everything new. Even though he might know about AWS, he has to learn everything new about how the whole thing has been set up, how the CI/CD has been set up, or how the architecture has been laid out, or the overall topology of the AWS. So we were not able to create a fungible team. And also at the end, I mean, we had other challenges like how do we patch everybody and other stuff, right? So the inconsistency between different accounts and then different application kind of slowed us down. So then we developed this platform. So this is how the service onboarding looks today. So a developer comes and then he enters the details on the service portal about his service, and then he chooses whether it needs to be a Java service, Node.js, it can be any service for that matter. So he posts the information about the service there, and then at the end of it, there are few things he gets it. One, of course, the documentation about the platform itself and how this platform operates and all. And he gets three repository. One to store his code so that he can collaborate with other developers and other team members. And second thing, something called a deployment repository, which we will talk about later. So he get another repository to manage manage the deployment of the application. And the third thing is, of course, the configuration repository, which a developer can use to push only their configuration. So we wanted to have the code and configuration separate so that they can push either code or they can push the configuration at later point of time if they need to make any changes. Then the team, the development team gets the build job. We use IBP, we call it a IBP2, Intuit Build Platform 2, which is Jenkins Blue version. So they get basically a Jenkins pipeline to generate the artifact. And then we use a deployment solution called Argo CD, which is used for deploying application into Kubernetes infrastructure. This is an open source one we will talk about in the subsequent slide, and it's open source by Intuit. And finally, his application actually runs on Kubernetes, so he gets a namespace. And since application runs on Kubernetes, it has to be a Docker image, or it has to be an image, and we use a Docker image. And this Docker image is stored in the Artifactory. We use JFrog for storing the Docker images. And of course, the development team gets one test execution platform to run their test. So he comes and fills in the information about his service and then chooses either Node or Java service. Of course, there is no limitation on the technology that he can use. This is just to give them a sample application when they onboard it. They can completely throw away the sample application, which is what they do, and then they put their code there, and their code can be in any language. It's not specific to the Java or Node service. And once he gives the information, and all it takes is around 15 minutes, he has the microservice ready. And along with the microservice, he gets the monitoring platform as well. So we use Splunk for logging and AppD for monitoring the application. Wavefront to push the analytical or different data about the application so that it can be alerted. And of course, the security is also inbuilt. So with that, we were able to achieve the velocity and ease of operability for the development team. And of course, the security was kind of built in. And all this takes is around 15 minutes today. I mean, we could have actually shown the demo. All it takes is 15 minutes. As long as a development team has some idea, all they need is just 15 minutes to get their infrastructure ready. And it became easy for them to operate because the infrastructure is completely abstracted from them. They really don't have to know any details about where it is running, which cloud provider it is running, what's the image version it is using. I mean, unless they want to know if they have some specific question on it, but they really don't manage those infrastructure behind the scene. And the second thing, of course, they need to know it is how to work with a Git, which every developers know day in, day out, they work on it. So for deployment, what they do, come to the Git repo and then make changes to their code. And once the code, any change is made, there is a webhook which triggers the build, and it can be any build. Again, the whole pipeline, the build job is within a Docker environment. This itself actually within a Kubernetes environment. So you can use Maven, you can use Ant, any build tool that you want, you are free to use it. Just for example purpose, we have shown Maven here, but you could use any build tool platform here to build the application. And once the application is built, it generates a Docker image. So that Docker image gets pushed into the Artifactory. So his new code with a new version of the Docker image is pushed to the Artifactory. Then the other repo which we talked about besides the code repo is a deployment repo. So the build job update saying that, hey, here is a new version of the Docker images available. And once the deployment repo is updated with a new version of the Docker image, the Argo CD constantly checks the Git repository and identifies, hey, there is something which has changed, which is with respect to here, the version of the application has changed. And then it checks the Kubernetes environment, what is the version running there. And if it sees a mismatch, it says, hey, there is a mismatch between what is your desired state or what you want to run in production versus actually what is running in production. Do you want to sync it? Of course, they can enable the auto sync, which means it automatically syncs, or if they want to have more control, when they deploy into production, they can kind of disable the auto sync and then go on need basis and then sync it, or maybe call Argo CD CLI tool or write some script around it to deploy the application into the Kubernetes. So only two places they'll work is their code repo and then their deployment repo. Anything happens behind the scene with respect to what's the EC2 instance we use, and then what's the image it is running, and how we have set up whole thing, it is completely abstracted from them. So this made much easier for the developer to work on the area where they are actually interested to work. Which is building the feature for the customer or fixing any issues in the code and other stuff, as opposed to spending some time on infrastructure and some time on coding. So a little bit on our journey. So we started all this thing way back in Jan 18, and that was a very small team. We started that time. Hey, by the way, I see there are a few questions posted. I'll pass it after a couple of slides once we talk about the number of namespaces and how the setup is. Then we'll take a few questions before we jump into the next section. Please bear with us. So the journey for so far, so it started around Jan 2018. We started to see whether we can run one specific application. We started with Kafka on Kubernetes. Then we kind of gained confidence that it can run the application at scale, at enterprise scale. Then we started with the dev and test environment and pre-prod environment since April 18. And it was started in a very small scale. But today we have around 220 Kubernetes clusters and more than 5,000 namespaces. And this is how our journey progressed. As you see, there are close to 2,300 application services within Intuit, the microservices. They are using the solution, and the adoption is just increasing. So we have around 50% or 40 to 50% of our application running on this platform. Rest of them are being migrated, or certain things are third party and other things which may or may not fit into the Kubernetes environment. But we are having more than 40 to 50% of adoption, and it's just increasing. And all these things happened over this last year. And we have around 5,000 namespaces. And we have around close to, in fact, we have around 200 clusters. And this dashboard, just picked it up some time back, but we have around 200 clusters in our environment. And this is the whole tech stack that makes this platform. It is not just Kubernetes. There are so many other technologies that we use. It's not about the technology. It's about how we stitch together all the technology and make it work for us. At the bottom of it, we have AWS, and then we have IKS, which is Kubernetes running on top of it. And then we are having service mesh, which will be enabling it pretty soon, and GitHub. So there are a bunch of technology that we use, and most of them are open source. And being a good citizen of open source, we have also open sourced our solution, which Ravi will be talking it pretty soon. And this is what the platform is. It's a self-servicing onboarding platform, provides a CI/CD pipeline so that the code can be deployed, rollback, or remediated pretty fast. And it runs on Kubernetes. And with respect to the scaling out application or scaling down the application, everything is in the control of the developers. Because it runs on Kubernetes, they can change the pod spec, they can change the HPA, they can have different HPA algorithms so that it can automatically scale up the infrastructure or scale down the infrastructure. And as a platform team, we take care of security, and we ensure which image should be running on the system. And since it's a Kubernetes Docker image, the application generally don't have to worry about the OS that we are running on the EC2 instance or the image. So those are things which something we take care of it, so that the security, everything is kind of ironed out and then taken care at the enterprise level. So today we will talk more specifically on the Intuit Kubernetes service, what it's made up of, and how do we manage it. We call it as a IKSM, which will open source if that's another product that we have, and then how the custom resources and other things that we have built. So Ravi will take you through those rest of the slides. But before that, we'll quickly see if we can answer a few questions.
Like I'll read out the questions. The first one is which things kind of told you that you should migrate from a monolith to a microservices based architecture?
See, it's based on the way we were actually deploying our monolith and all. It was taking long time, right? I mean, every time if you have to make a change and then build a huge monolith and deploy it, it used to take a month before the code gets into the production. So there are many challenges in the monolith. So the reason for us to break down into microservices is to how do we make these things simpler and easy for developers and other team to push the code faster and then have a higher velocity.
Sure. So the next question is, when you say 200 plus clusters, how big is each cluster in terms of nodes and pods running on it?
Ravi, you want to answer that one?
Sure.
You are expert there.
Sure. So each cluster, we have a varied number of nodes, but typically we host anywhere between 500 to 1,000 nodes based on based on the applications running on it. We have clusters that have more than 900 nodes running on it. At a maximum today, we cap at 1,000 nodes, and a number of namespaces. Again, we look at somewhere around 250 namespaces per cluster. That's what we cap at today, but it is not just limited to it. We can expand even further. But for our management purpose and having it operating successfully, we have decided on these numbers. Pods, it depends on how many resources the pods use based on the nodes and the namespaces and stuff like that. They vary.
Yeah, and also the number of nodes vary based on the size of the node we choose on the specific cluster. So there are many factors, but there are really, really big cluster, and there are certain things at the medium level wherein if you have to take the PCI complaint or some kind of complaints where only certain application can run, then we have kind of small clusters as well.
Sure. The other question is, are there provisions to configure Argo to schedule the update according to the data center maintenance windows? Today, we don't do it. Maybe I'll answer this like, sorry. Today, we do not do an auto update by running an Argo workflow and stuff like that. But what we do is we have a scheduled, maintenance window that we kind of rolling updates is what we do across the Kubernetes clusters. For that, usually we do it on a sprint basis. Every sprint, once we are done with the changes, we kind of upgrade our clusters, typically using GitOps model.
Okay, Intuit does DevOps consulting as per pre-prod and prod comparison graph. I didn't get the question.
Maybe they are asking, does Intuit do a consulting on the DevOps side?
Oh, okay. We don't do consulting work. Of course, we are always willing to help on our open source stuff. If you have any question regarding Argo CD or any of thing on the Kiko project, we will always like to get back to you and then answer your query. But as such consulting, we don't provide. The next one is.
I think the next one is a good segue to get into the next section of the talk. So we'll keep hold this rest of the questions like this and answer at the end of the talk, because most of them might get answered based on what we are going to tell you now.
Yeah.
Okay.
Thanks, Ravi.
Thanks, Lex. Go ahead and share my screen. So let's look at typically what forms a Kubernetes cluster, right? So a Kubernetes cluster generally has two things, right? One is a control plane, the other one is a data plane. So in a control plane, we have master nodes that have all the critical components installed in it that manage the rest of the cluster. In the data plane is where we deploy our applications, which runs all the services. Now, in order to run Kubernetes clusters, we also need a place to store all the Docker images that our applications will fetch the Docker images, and then they run on these EC2 nodes or the worker nodes in the worker data plane. Now, we also use other services because we are running on top of AWS. We use ALBs, to use it as ingress so that we can redirect the traffic from the external networks into the specific applications. We can route it based on the configurable URL paths and stuff like that internally if we have more than one service in a namespace and stuff like that. And there are a bunch of other components on the AWS that we use, like CloudWatch monitoring or logging aggregation using Kinesis and analytics and stuff like that. So all these things at a high level constitute a Kubernetes cluster. But let's look at the challenges that we faced when we started with a bare minimum Kubernetes cluster that we installed on AWS. So today, many applications tend to run on a single Kubernetes cluster, right? So most of the time what happens is every application try to manage their own log forwarding mechanisms or metrics or DNS lookups and stuff like that, whether the application is able to reach to the a third party DNS or not. And all these common functionality, if we are running outside of a Kubernetes cluster, every application kind of builds it on their own. But when we bring all these applications together and put them on a cluster, having them run independently will kind of bring in additional cost on the resources, and there is a lot of overhead. There is a lot of duplication also that can happen. So that is one of the challenges for us to solve. The other challenge is when we are running the Kubernetes clusters, we should also integrate tightly into AWS services, right? Because we want to leverage ALB on the AWS, not bring up our own ingress service using some Nginx ingress services and stuff like that, right? The reason for that is ALB provides a lot of security advantages in terms of preventing from say SQL injections or cross-site scriptings and all that security issues are taken care of with the WAF compliance in ALB. So we want to leverage that. Now that possesses a challenge to kind of integrate from a Kubernetes into talking to services on the AWS, right? So this is one challenge that we have seen. The other challenge that we have seen is how do we configure a multi-tenant environment in a Kubernetes? It's not that one application runs or one specific segment of a team runs, right? It's all the multiple teams across a particular business unit probably try to run in one common cluster. In that case, there can be multiple, smaller teams that may want to deploy their application in a particular cluster, right? And they need some space to run that particular application in the Kubernetes cluster. Now, how do we define that component? What is the unit of multi-tenancy that we define? We thought a lot about this, like whether we need to create a Kubernetes objects with the same label, we quantify them as one multi-tenant, or some sort of CRD that kind of attaches all these customized labels, or brings when a particular deployment is run based on the timestamps and stuff like that, we qualify them as one namespace or one tenant, or should we call a particular namespace where all the components of one application run together as one namespace, right? So this is a thing that we thought about a lot and finally decided upon using a namespace as a unit of multi-tenancy. The good thing is this stood the test of time for the last couple of years, and we are able to operate successfully by deploying applications in individual namespaces so that we achieve high multi-tenancy. But when we run the applications in a namespace, but all the applications are running in the namespace, but namespace are cut across all the worker nodes, right? So what happens is when multiple applications are running, probably a pod of one given application might be taking more resources on a given instance, and another application pod running on the same instance might not be getting the required resources that it needs. So there is a noisy neighbor problem that we run into when when we operate it like that. The other thing can be that a particular application team might want a specific type of AMIs, which is machine images, that they need probably for their security purpose. Or some teams, let's say if there is a data processing team that may need higher CPU memory than other teams that runs, say, microservices for using Java and Spring Boot, right? So, every application will have its own requirement, and they need a specific type of instances. And how do we qualify cost accounting, right? The primary reason, one of the things people will look up to when they move to Kubernetes is, hey, by moving into Kubernetes, because things auto scaling is managed by Kubernetes inherently, how can we get a cost benefit out of it? Now, also how we can show that a particular application is consuming so much amount of billing, right? How do we associate a billing to a particular application? That is another challenge, right? So all these things have made us think a lot, and in the meanwhile, there are other challenges that we encountered on monitoring, right? It's not enough for us to check if some components are up and running, like say some pods are up and running. Are we good there? No, we need to go and exercise the functionality periodically on that pod. Say example, we need to go and check periodically that we are able to reach to an external domain DNS, example www.google.com. We are able to hit it, which means our cluster DNS is working. Or we may want to go and check if we are reaching AWS limits or not. If we wait till the end, we may run into a production issue. Maybe we need to know it early in hand. And we also need to check we are consistently able to access S3 buckets if application teams use them, so that nobody overrides some policies which we may need. Once we find the issue, it's not enough we find the issue, right? We should also be able to immediately remediate them automatically. Otherwise, the whole benefit of recoverability might be lost. So we need to be able to remediate some of these issues as soon as we find them. How do we achieve this? This is another challenge. One other dimension of the challenges is resiliency and hardening, right? In Kubernetes repo, if you go and look for how many issues are there around pods stuck in a terminating state, you can find thousands of such issues. Now we cannot wait until all those issues are fixed and then start using Kubernetes. So what we need to do, we need to kind of look at the pods that are in this terminating state for an X amount of time, say more than 1 hour or so. Then we should go ahead and delete those pods. We often see that under scale, sometimes the EC2 instances, although they are shown as available, but they may not get registered properly in the Kubernetes, and that kind of poses other challenges when ALB is trying to send traffic into the pods via the nodes, right? So there can be other challenges with that. And when we do a cluster upgrades, we often run into issues where ALB holds keep alive connection to the pods, and when we do the upgrades, the node is terminated, which means the pods are also terminated. So the keep alive connection between the ALB and the pod is terminated. So if a request is getting processed in that keep alive connection, that will be closed, and the client gets a 502 error on his end. So these are some critical challenges that we face, and this is one more dimension. And the other dimension that we discussed briefly in the cost accounting is there a way we can get reduced bill when we run applications on Kubernetes on AWS, right? Are there any options that we can leverage so that dynamically we can switch between spot instances versus the on-demand instances? So we thought how we can optimize and bring cost efficiency into the picture when applications run on Kubernetes, right? So we had these challenges and we came up with some solutions for it. Let's look into what the solutions are that we came up with. So the first thing is when all the teams need some common functionality, we thought of looking into add-ons that are available both in the open source as well as add-ons that we could build. So let's say this is one example where we can deploy this add-on in the Kubernetes cluster. This is a Fluentd add-on that we can deploy in Kubernetes cluster that kind of ships the logs from nodes into the any logging provider. Here we use Splunk. So this is how we configure it. Now, this entire thing is packaged under a CRD. CRD is nothing but a Kubernetes custom resource definition. So we built this add-on manager, which provides this custom resource definition so that we can submit custom resources, which are wrapped around Argo workflows. When we say Argo workflows, you can define what action you need to do internally. Here, the action that we can define here will be install the Fluentd add-on in the cluster. So we can define all these things in a workflow and wrap it over a custom resource, and that that kind of provides us a flexibility to deploy multiple add-ons that we need to provide to the applications so that they have a meaningful existence in the cluster, right? So we have come up with this solution called add-on manager for that. Now, in order to resolve the multi-tenancy issues like noisy neighbor problem or customized, instance types and other things, what we decided to do was we'll create instance groups per namespace. So every instance group, an application team can configure what kind of instance they want or what kind of labels they want to associate with it, or if they want to associate some tains and other things on that particular nodes or attach some security groups to it and stuff like that, they can configure it, and we provision them in that particular namespace. Also, one thing that we decided is, although we give the ability for the users to configure their own instance groups for their namespaces, one decision that we took was when we do the upgrades on the cluster, we will upgrade it across all the namespaces together. In the sense, all the namespaces will run parallel upgrades of, say, Kubernetes version that gets updated on the nodes and stuff like that. So the upgrade mechanism is chosen to be centralized across the cluster. Now, the other thing that we came up with for a solution to create the instance groups, right? Instance groups are nothing but, if you talk in the AWS language, they are auto-scaling groups that we create in the AWS, right? So, but in order for that to be translated into Kubernetes object and be able to manage directly from the Kubernetes itself, so that we don't even have to log in into AWS to look into what we have configured and stuff like that, we can use something called instance manager. And in here, not only we can bring up an ASG with the nodes running in that ASG and stuff like that, but we can qualify them with some labels and tains so that they can say that only the application parts of this namespace with some specific labels will be deployed on these nodes, and no other application parts will be running on these nodes. So all such tains and other things we can attach to these nodes using this instance manager, and we can attach some security groups and stuff like that. We can also define what kind of upgrade strategy we want in our particular instance group nodes, so that maybe we can define how much percentage of availability we can choose when the upgrades are happening. Like it's okay for me if 50% of the nodes are not available, we can configure that strategy. Here default, we go with a CRD strategy, that is it goes with a rolling upgrade. Now, in order to solve for the deep monitoring to exercise the functionality of different use cases, we have come up with another solution called Active Monitor. It is also a Kubernetes custom resource controller that provides us a CRD so that we can wrap around Argo workflows. Now, what we can do with this is it kind of, once we submit that custom resource into the controller, we'll pick it up, and then it launches an Argo workflow. Then it exercises that functionality of whether it is a DNS check or whether it has to monitor some Kubernetes resources or AWS resources, maybe modify some policies dynamically based on the usage, or if some security risk has thrown because of some policy is not right, we can dynamically change it using this. So this is how a typical custom resource of the Active Monitor looks like. We call, we can define the health check that we want to do. That is, it kind of monitors this periodically. Here we are configuring it to run every 60 seconds. It kind of checks if the pod memory usage is more than 95% or not. If it exceeds 95%, here we are configuring another remedy workflow, which will go ahead and resolve that issue immediately. Once it fails, it will go ahead and trigger this remedy workflow where we go ahead and delete that particular pod. There can be a number of use cases, like we can go ahead and increase AWS limits, or we can look for pods that are in the crash loop back off state and probably go ahead and delete them so that fresh pods comes up cleanly and stuff like that. The other solution that we have come up is, upgrading a Kubernetes cluster has to be done very carefully so that it doesn't impact our applications running on it or the transactions that are being run across the clusters, right? So we have come up with a solution called rolling upgrade. It's an upgrade part of upgrade manager. So rolling upgrade is a CR type that we define, and it kind of upgrades the instances one by one across the cluster. And it can also provide an ability to parallelly process the upgrades across the instance groups. So if each application has configured its own instance group, Upgrade Manager will take care of upgrading all of them in parallel. The last thing we have seen the resiliency and hardening issues, right? So in order to achieve higher resiliency and availability and other things, we can also use something called governor. What it does is it essentially goes and terminates all the stuck pods, and it will also go ahead and carve down the nodes that are in a bad state and delete them after a certain point in time. And in order to achieve the cost efficiency, which we were talking about, if we can leverage the spot instances or not earlier, we have come up with a solution called Minion Manager. Again, this is another CRD that runs in the Kubernetes cluster. What it does is it kinds of checks if a spot instance is available and what is the price of those spot instances. It compares them with the on-demand prices. If we get a cheaper spot instance, we kind of update our instance group so that we can leverage the spot instances. So there will be a flip that will be done so that our on-demand instance will be replaced with the spot instances. So with that, we achieve a lot of cost efficiency. Now, this is a risky thing to be done in production usually, but what we have done in order to eliminate the risk is we are using it in our pre-prod environments. All the dev clusters or pre-prod clusters or E2E clusters and stuff like that, all of them use Minion Manager so that we can achieve the cost benefit using the spot instances. The other thing is, one day security team came to us and said, hey, it's good that you're operating all these things, but in a regular cloud provider of AWS, when services were running on AWS, we were able to get into the nodes and get everything that we want in terms of security related information. How do we achieve that in the Kubernetes, right? Because we want to secure our pods, we kind of delete all the debugging tools in the pods and put them in production, right? Now, if security team wants to look into and kind of process some data, how do we get that? This is where we leverage the Docker functionality called Docker checkpoints. Now we enhance that in Kubernetes, and we came up with this Kube Forensics project. What it does is it also does a pod checkpoint where it kind of takes the snapshot of the pod and puts it into an S3 bucket and makes it available for the team so that a security team can do the forensic analysis on that pods. So all these different independent open source components put together form Kube project, and this is used heavily to manage Kubernetes clusters at scale. If you look into all these things put together, today our Kubernetes clusters will look like this. It will have a control plane that has all the default controllers that KOps clusters or EKS clusters will bring in. It will have the all the management done through that control plane. And then on top of it, we have add-ons that we install. If we are using KOps, some of these add-ons can go into the master nodes. But if we are running on EKS, we can have a separate system namespace where these add-ons can be run on them. And then on top of it, we have namespaces where the applications run on. This is how our Kubernetes clusters today look like after all these challenges have been resolved. So this is a Kiko project, GitHub URL. And if you want to follow the updates on what is happening on a frequent basis, you can subscribe to this Twitter feed. The next project that Intuit open sourced and which we heavily use internally is Argo Project. Now, in Argo, there are multiple components. One is Argo CD, which Lax explained earlier in the demo, where we have seen how the entire GitOps flow work to achieve faster deployment model, as well as improve the velocity of deployments and stuff like that, right? So Argo CD will be able to achieve that. And we have other components like Argo Workflows, Argo Rollouts, and Argo Events. Let's look at what these individual components do. So at a high level, Argo CD is a declarative GitOps continuous delivery tool. We define our application definitions like deployments or pod specs and other things, and the configurations and environments and other things in a GitHub repo. The reason we want to do it in such a way is that there should be version control. Also, overall, they should be declarative in the sense we define them in a YAML file that Kubernetes, Kubernetes supports and stuff like that. And Argo CD internally also has a versioning control, in the sense if you deploy a latest version and if that gets into an issue, you can immediately switch and roll it back to a previous deployment where it is operational 100%. The other thing Argo CD provides is, it provides the ability to audit and be able to deploy automatically. It provides a complete end-to-end automation on deployment of applications in the Kubernetes. So the critical thing we get out of this entire GitOps model that we leverage with Argo CD is compliance, auditing, and version controls. So this is one of the major advantages, and Argo CD is pretty popular in that domain. The other tool that we have seen earlier in a couple of controllers that we have were Argo Workflows, right? So Argo Workflow is again a custom resource controller. But what this Argo Workflow controller does is it provides a container native workflow engine so that we can orchestrate multiple Kubernetes jobs. Either we can run them sequentially, or we can run them parallelly, or we can use DAGs to run these workflows and stuff like that, right? So this also provides a UI view where we can look into in a workflow sequence. If we run one particular pod, and in the next phase we can run parallelly multiple pods and stuff like that, we can from the UI we can dig into deeper and what is the log messages that we are getting. For example, here we are printing hello Kubernetes, and in this pod we are printing hello Argo and stuff like that. But it can be much more complicated than this. So all these things we can configure using Argo workflows. And this Argo workflow project is heavily used by Google in their Kubeflow engines for the machine learning purposes. The other critical thing that we do from the Argo from the Argo project is Argo Rollouts. This is also another Kubernetes controller, but the advantage that it gives is that it provides an ability to control the deployments in a much more granular way, and the way we are used to when we were operating in, say, pre-Kubernetes world, right? In AWS and other places, we use some tools like Spinnaker and other things that kind of provides us an ability to do blue-green deployments. But if we directly rely on plain vanilla Kubernetes version of clusters, and Kubernetes does not provide a way for us to do the blue-green deployments. It only provides us two options. One is to delete the old version of the deployments and then deploy the new version. The other option is to do the rolling deployment, right? Your new pod comes up and then your old pod gets terminated. But oftentimes what happens is, in order for, if you go with the rolling update and stuff like that, if the number of pods in your application, say, are some 500, right? It takes a lot of time for a rolling update to complete. But instead, what you can do is you can use Argo Rollouts, which provides an ability to create a blue-green deployments or canary deployments or progressive deployment, delivery deployments. So let's look into what these are. A blue-green deployment essentially means that along with your running application, say V1 is your version of your application that is running, you can also deploy a version 2 of your application, right? Then what we can do is we can go ahead and test the version 2 runs fine and stuff like that. After a certain point, when we are confident that version 2 is running fine, we can then switch the traffic from application 1, the version 1 of our application, to version 2. So all the traffic now goes into version 2 of our app, and we can keep these pods for as long as we want as a backup. Once we are confident that, hey, version 2 of our application is running fine, then we can completely remove these pods, or we can remove the deployment entirely, so that the whole thing works with a single application deployment. Now, again, at a later stage, in another sprint, we come up with some user stories, we fix it, and again, a newer version of the pod can be deployed, and both of them can point to that particular pod. And if you have observed it closely, all that we are managing it with this in the Argo Rollouts is through labels, right? So in the first version, we have the label here is V1, template hash is V1. And when we try to switch the traffic, we upgrade the label. When we promote from the older version to the newer version on this application, we just rename the label such that all the traffic gets switched into this one. So we operate the Argo Rollouts like this in a blue-green deployment model. It also supports canary model, where in canary model we can split the traffic between version 1 and version 2. And as we feel confident on version 2, we can slowly increase the traffic on the version 2 of our deployment and move the entire traffic there slowly. There is another version, another model of deployment which is getting popular nowadays is progressive delivery, which means that it is kind of a canary deployment, but all the analysis is built into the controller, where we can submit what kind of analysis we want to do before promoting the traffic from say version 1 of our deployment to version 2. So we can define different steps, like for the first 1 hour, if there are no errors, then we can promote 10% of the traffic from version 1 to version 2. And then again, we can define another step saying in the next 2-3 hours, if there is no issue, we can promote 50% of our traffic. Slowly, the progressive delivery will shift all the 100% of traffic to version 2 if everything is looking good. At the same time, it will also revert the traffic back to version 1 in case if there are issues found. So that's a new model which Argo Rollouts started supporting pretty recently. We should, if you're interested, please explore that. The last thing, the Argo project has is Argo Events. So in the Argo Events, what we do is we kind of consume events from various different sources. These are some sources where we can consume events from, but they are not limited to them. These are just for example, like a GitHub event or a Slack event, or let's say event from Kubernetes resources, or SNS topics in AWS and stuff like that, or your calendar events, or even S3 bucket events, right? It can consume any one of these events, and we can define the workflow that we want to run if such an event happens, or we can define a Kubernetes job that we want to run when such an event happens, or a Lambda function that we want to run if any one of these events happen. So this is a pretty strong model that kind of allows us to handle the events and act upon them accordingly. So again, this is the GitHub repo of the project. If you want to know the latest updates on how Argo project is kind of developing new features, or where it is being used and stuff like that, you can subscribe to this Twitter feed. Beyond this, we are also doing a lot of stuff on GitOps for AWS resources. Today, all the resources in AWS they are provisioned using either some CloudFormation stacks, or we write specific Ansible scripts, or kind of Chef scripts and stuff like that. But we are coming up with a GitOps way of doing provisioning the resources in AWS, and then we are working on having a multi-cluster service mesh using Istio. We've contributed to a project called Admiral. It is now part of Istio major project that kind of does a multi-cluster service mesh. And then we are exploring open telemetry. We started using it in some of our clusters, but we are evangelizing more on the open telemetry side. So until a couple of months back, we were using a KOps version of provisioning the clusters. But in the last couple of months, we have started rolling out Kubernetes clusters with AWS EKS, and we are continuing our journey on that. So with that, there is a lot happening in Intuit. If you are interested, please look out for Intuit careers page and start applying if you're interested on working on this side of things. Thank you.
Yeah, or even if any of your friends are interested in working on open source, Kubernetes, or any other things, feel free to refer them. And there's an NPS survey. Please take that one. And then, yes, it's on your screen. Yeah, start taking it. While we answer a few questions here, I try to answer a few on that one.
Okay.
So, how are we handling logging and external and APM metrics?
Okay. Can I answer that?
Yeah. Hey, fine. Go ahead, Ravi.
Sure. So today we are using Fluentd that ships the logs from all the nodes where all the pods put the logs into one common location, and Fluentd ships them from the nodes into the Splunk endpoint. That's one way, but we have seen that Fluentd scales only to a certain extent. So we have now come up with another alternative solution called FluentBit that does this log shipping. We have other custom solutions to scale even more, but they are not kind of open source yet. And in terms of APM metrics, so what we do is for our applications, there are a bunch of monitoring tools that we use. One is Wavefront that kind of gives us the metrics on the cluster-wide resources like nodes, pods, and stuff like that. And application teams can also expose their metrics into Prometheus, which Wavefront will pick it up and show it in the Wavefront dashboards. So primarily on the cluster-wide resources and on the application resources at a resource level monitoring and other things, we use Prometheus and Wavefront. But in terms of diagnostics and in terms of knowing all the method level details and stuff like that, we use a tool called App Dynamics.
App Dynamics.
App Dynamics.
Yeah. Of course, we use a lot of open source tool, and then we use some tools like App Dynamics, Splunk, and in fact, we were using New Relic at some point of time. So we have a bunch of tools to analyze the application performance, because that's very critical for us to have a good uptime and also have a faster response time to the customers.
Yeah. And as we said, we are exploring on the open telemetry. We started implementing eager tracing tools in some of our clusters, but we'll continue on our journey, and maybe we'll share some lessons down the line.
Okay, I'll take one more question. You mentioned that you are replacing on-demand instance with spot instances to cut cost, but the spot instances are unpredictable since it could be taken away in case of a higher bid than yours. How do you manage this situation? Maybe I'll start, Ravi, you can add more details. Yes, that's precisely a problem with the spot instances. That's the reason we use it only in pre-prod, because in pre-prod, it's mostly developer will be using it to test their code and other thing. It's okay sometime. I mean, if you lose the instance because other node can come up, and then the pods can come up there and then pick up the request. And most of the time there are multiple pods running, though they can take the request. Yes, it's a problem, but that's why we use it only in pre-prod and nothing on production.
Sure, I think that answered the question. The other question is, I agree ALB provides a lot of features, but if you're not relying on ingress from cost point of view, is it worth exposing all your services on load balanced with ALB? I think one of the critical things that ALB provides is, as we discussed on the security side, other than that, we can attach some security groups and other things where we can also limit who can access a particular service and stuff like that. So for us, because we are financial products that we develop, it's security that is the most critical thing for us. So then comes cost and other stuff. So we are okay to bear with that.
Yeah. And also, I think with the service mesh in place, we'll be replacing ALB so that we can have a inter-cluster communication also along with the service mesh. So there are some work happening, in fact, there. I think we are almost on time. Thank you all. And of course, we'll be sending us another survey link to see how we can improve the overall the engagement and then the virtual talk process. So please answer the survey. That would help us to do the better job next time.